Okay, I'm working on the Chapter 7 test, the chapter test out of the textbook that you guys were doing as kind of a review to get ready for your Chapter 7 text. I'm just doing a few selected problems based on ones that you guys told me what with, so if I don't do the one you need, feel free to give me a call or text or something and I'll see if I can help you. So I'm going to start and for some reason my pen is not working very well. Trying to draw again. Not doing a pretty job. Okay, they told you these are similar problems or similar shapes. They don't look it in my picture, but we're just going to assume they're right. This side is 8, this side is 8. Y, 42 degrees. This side is 12. Over here we have 6 and 6. This side is Z, and this is X. My pen is acting very funny right now, so sorry guys. Alright, let's start with X. They told you these are similar figures. Well, in similar figures, the sides are all proportional and the angles are all the same. So, X is equal to whatever its similar angle is. X is equal to 42 degrees. That's kind of our easiest one. For Y, we need to find the angle up here in this corner. Well, we know that this is a quadrilateral. It has 4 sides, so it needs to equal 360 degrees total for the entire shape. And so far we have a 90, a 90. They've given you 2 right angles in there, so those are both 90. And we have 42. Well, you add those up and you get 122. Subtract that from 360. And you get 108. So Y is equal to, shouldn't have written that there, 138 degrees. So Z is probably our hardest one. For Z, they've already told you similar figures, so we're going to create a proportion so we can figure out what Z is. Well, in our big triangle, we can see that this top measure is 8 and this angled side is 12. So I'm going to use that. Top over right side, that's my ratio, is equal to the top over the right side of my smaller shape. And if I cross multiply, I have 12 times 6 equals 8 times Z. 12 times 6 is 72 equals 8Z. Divide both sides by 8. And you have Z equal to 9. All right, number 15. Because I just figured out how to use different colors, I'm going to use a different color. Number 15 is finding a geometric mean. That means in number 15 they gave you 2 numbers, 4 times 9. To find a geometric mean, you multiply the 2 numbers together. 4 times 9 is 36, and you take the square root of that number. So the square root of 36 is 6. That's all you have to do to find the geometric mean. They aren't always going to be that pretty though. Number, I didn't write down which number this one is, but it's 6 and 12. They gave you the numbers 6 and 12 and they said find the geometric mean. Well, 6 times 12 is 72. If I find the square root of 70, it's not a perfect square. 36 was a perfect square. And if you don't know that, you need to go back and memorize your perfect squares up to 15. It'll help you out a lot in the next couple years. 72 is not a perfect square. So what we do with that information is try and break it down into something that is a perfect square times something else. So in this case, 72 is equal to 36, which is a perfect square, times 2. I can take the perfect square portion of that and put it out in front. So the square root of 36 is 6. And the rest of that number just stays under the radical. So the answer is 6 square root of 2. All right, number 18. Pick a brighter color. This one gave me some trouble. And part of that reason is because of how they drew it. And of course, I'm not doing it any justice myself. If, this is what they gave you. I think that's all they gave you. So when I tell you to, what we're working with here is a right triangle that had a altitude drawn from the right angle across to the hypotenuse. So therefore we have split this into 2 more right triangles. And they're all similar. They're all proportional. So this is where we use our little chart that I made up. In my chart, I say I've got my small triangle, my medium triangle, and large triangle. And each of those triangles has a short side, a long side, and a hypotenuse. And I fill in all these spots and I see what kind of ratios I can create. The problem with this one is that the drawing makes it a little hard to figure out which side is which and which triangle is even which. This triangle on the left is our small triangle. I'm going to write small. This one is our medium triangle. Of course, the whole big outer triangle is our large triangle. In the small triangle, it's really hard to tell what is the short side and what's the long side. Now this, since this is my right angle, this is my hypotenuse. So I'm going to go ahead and label that. That's 10. That's sort of the easy one. If you can't tell which is the short side and which is the long side, then the next way to go about that is to say, well, let's look at the relationship between the sides and the hypotenuse. If you go hypotenuse to the right to the triangle, or I said that backwards. Hypotenuse to the right and then to my right angle. This is the side between, I don't even know how to say it. Let's say this one is to the, see what I really need to do is draw it down here. Like this. And this is my short, this is 10, obviously. Here's my right angle. And this is 6, and we don't know what this is. And it turns out that that 6 is my short side. And I don't know what my long side is. This is my long side. Well, the long side of the short one is the short side of the medium. So I don't know what that is either. Which means this has to be the other leg. So it's going to be x minus 6. So once you establish which is the short side and the long side of your small one, then it kind of helps you figure out what the medium was, because the long side of the short triangle has to be the long side. I said that wrong. The long side of the short triangle has to be the short side of the medium triangle. And then hypotenuse of the medium triangle, I don't know that either. Now in my big triangle, again, a little hard to tell. This is my short side. Now that I've drawn the small one and faced it the same direction as the big one, you can see I'm comparing this side to this side. Short side, short side. When they're all turned around different directions, this can be pretty hard to tell. So you might want to redraw them sometimes. That might help you a little bit. I don't know the long side of my big triangle. But I do know my hypotenuse. It's 6 to get to here, and it's x minus 6 to get to here. So it is those two things added together, 6 plus x minus 6. Well, it turns out that those two cancel, and we're just left with x. So now I can look at this and try and create some proportions. If I work in the same columns, I can say, I can put this over this. I'm comparing the short side of my small and my large triangle, 6 over 10. And over here, I'm going to compare the hypotenuse of the small triangle and the hypotenuse of the large, and that is 10 over x. If I cross multiply those, I get 6x equals 100, and if I divide that by 6, x is equal to 16 2/3, or 16.66. Either one will be fine. So set up your tables. This one was particularly hard because of the whole, you couldn't tell which sides were the short, the long, and the hypotenuse necessarily of each one. So I admit that one was a little bit tougher. All right, number 19. Looked something like this. They gave you a triangle. They told you that these two angles were equal. And when they tell you that, let me look at my book. When they bisect an angle in a triangle, it lets you know that the triangles are proportional. So they told you that this side was 12 and this is 6, and we don't know what this is, and this side is 20. So I can compare these two triangles. I can say this side of the triangle compared to the base, I'm going to call it the base even though it's basically on top, is equal to the side of this one over the base of that one. And if I multiply that out, I get 12x equals 80, or no, I can't add to these, or multiply or anything else. 120. Divide each side by 12. X equals 10. Well, if you go back and look at this, that makes sense. If these sides are now a ratio, then, and this side's 6 and this side's 12, then this side is twice as long as the base. And so if this is 20, then the base has to be half the length of this side, and 10 makes that work. Work on number 23 now. Here's what's going on with 23. Let me try and draw it for you. They told me these two lines are parallel. They told me that this is 24 and this is 36. They told me that this is, and this is x plus 15. And they start out by asking how you know these are similar. So to get that answer, we look at this and say, well, these are parallel lines. So that makes this line across here a transversal, and this line across here a transversal. Well, our laws of parallel lines told us that this angle and this angle are equal to each other. And this angle and this angle are equal to each other. So the rule that lets us know that these are in fact similar triangles is angle-angle similarity. The next secret to getting this problem is to figure out what exactly you're trying to compare. What we have here is a big triangle that has a base of 36, has the side of x and x plus 15, and then we have a smaller triangle that has a base of 24 and x plus 15. So make sure that you're comparing the correct things. The big triangle, if we're comparing the whole base, we have to compare the whole side. So this makes this a little different than some of the other ones we did. If they had given us the opposite side, we could have compared, we could have said x plus 15 over b is equal to x over a. And we wouldn't have to compare big triangle compared to small triangle. But because we're using this other side, this base, I keep calling it the base, and this base side, and not the sides across the parallel lines, I have to compare the entire triangle. So I have a big triangle and I have a small triangle, which means I have to add these two sides together. So this is really 2x plus 15 for the length on that side. So if I compare my base to my long side there, I have 2x plus 15 equals base over long side, and I get 24 times 2x plus 15 is equal to 36 times x plus 15. And if I did my math right earlier, this is 48x plus 360, and this is 36x plus 540. Well, I need to get my x's on one side and my other numbers on the other side, so I'm going to subtract 36. I'm going to run out of room. And I'm going to get 12x over here. And this is 0. And I need to move this number over here, so I'm going to subtract 360. And over here I get 180. So over here where I have some more room, I have 12x equals 180. Divide each side by 12, and x equals 15.